My name is David Smith, and I'll be your host for today's session. But before we get started with today's session, there's some general housekeeping items I'd like to step through for today's virtual safety connection. The audio for today's session is through your computer speakers. That said, you may want to consider using a headset or earbuds for better sound quality. And also, in an effort for us to reduce the amount of background noises from different locations, we have muted all the participants' microphones. That said, you may want to consider muting or turning off other devices within your general workspace just to avoid any distractions that you might have at your end. We will have a question and answer period at the end of today's session, and we encourage you to ask your questions as you think of them. To do so, what you can is get into the chat feature, which is located where in the top ribbon where the bubble, where the three lines are. You click on that, and a side panel right here will appear. You can type in your questions there, and we'll do our best to work through as many of your questions as we can at the end of today's session. If you wish to make comments throughout today's session, we encourage you to do so as well in the chat feature. But please keep in mind that this here is an open platform, so what you type into the chat feature can be seen by all the participants on today's call. If you're like me, you like to view things in full screen mode. To get to the full screen mode, you can scroll down to where the three dots are, or the More Actions Items menu in the ribbon, and scroll down to where it says Enter Full Screen Mode. To exit full screen mode, you simply do the same thing, but in reverse. You just hit the three dots, scroll down to where it says Exit Full Screen Mode, and it take you out of full screen mode. You can also press the Escape button as well. We will have a few polling questions in today's session, and we encourage you to do your best to answer the poll questions. And we're going to bring the polling questions across in the chat feature. So again, it's going to be that bubble with the three lines in, kind of like the old cartoon style things. And then we'll ask that you answer the question. So there's a couple of different types. We're going to have polling questions like you see here, but we'll also have one where it's more interactive and you type in the answers in the chat feature. Don't worry about getting the questions right or wrong. We just ask that you do your best to answer them, and we will cover them off as we get through them. Today's session is an information session only. We do not consider it to be training. And there are a couple disclaimers we want to cover off. First is from Workplace Safety Prevention Services. This is a copyright presentation, so we will not be sharing it. And we also use some images from Getty Images, and we use them under license and copyright permission from Getty Images. Prior to the pandemic, we used to facilitate what we called network knowledge exchanges. That was a bit of a tongue twister for me this morning at various locations throughout the province. And with the pandemic, we wanted to continue to stay in touch with individuals like yourself. And we recognized that the virtual platform was a great platform for us to do so. So since that time, we've introduced this platform of Safety Connections, and it gave us an opportunity to stay connected with industry peers like yourself, but provide you an opportunity to attend today's session from the safety of your own personal workspace, and also to reduce the travel. It also gave us an opportunity to go from a regional setting to a provincial setting where we can have a broader audience attend today's session from many different sectors. That said, we encourage you to take what you learned from today's session, share it with your colleagues, and discover what's of value to you. And now it gives me great pleasure to introduce today's presenters. And first I want to introduce Mr. Sean McCormack of WSPS. Sean is a senior health and safety consultant with additional expertise in ergonomics. Sean provides consulting, risk assessment, and training to member firms in Western Ontario. He was a project co-lead for the Workplace Safety Prevention Services EV project, developing the white paper, and is continuing to work to help Ontario businesses better understand the risks of working with battery electric vehicles. Sean is a Canadian certified professional ergonomist, a registered kinesiologist, and a Canadian registered safety professional with 15 years experience. Prior to joining WSPS, Sean worked in the automotive parts manufacturing and construction industries. Good morning, Sean. It's good to see you today.
Morning, Dave.
Next, we have Angela Cameron. Angela is a consulting services manager with WSPS with over 20 years of safety experience in the automotive and service sectors. Angela helped lead the development of the EV white paper and supporting job aid in collaboration with industry partners in various sectors and educational institutions. Angela is a Canadian registered safety professional. Good morning, Angela, and welcome.
Good morning, Dave.
And on the panel discussion, we have a couple of guests here that I would like to introduce. First, we have Trevor King. Trevor is a provincial specialist in the Industrial Health and Safety Program at the Ministry of Labor, Immigration Training and Skills Development. Trevor started with the ministry in 2015 as a regional ergonomist, assisting inspectors across all programs while also leading his own proactive and reactive cases. Since then, Trevor has worked in the prevention division as a strategy advisor and in the fair, safe, and healthy workplace division as a senior evaluation and planning coordinator. With his combined research and consulting expertise, Trevor has approximately 19 years of occupational health and safety experience. Good morning, Trevor, and thank you for joining us today, and welcome.
Good morning, Dave. Thanks for having us.
And next we have Shelley Spear. Shelley is currently provincial specialist in the Industrial Health and Safety Program at the Ministry of Labor, Immigration, Training, and Skills Development. Shelley started with the ministry in 2005 as an occupational health and safety inspector as part of the High Risk Initiative. Her time at the ministry has been spent conducting inspections and investigations of industrial workplaces, as well as providing regional assistance as program manager to the Hamilton East, Hamilton West, and Blue Water Management units. Prior to coming to the ministry, Shelley worked as an environmental health and safety manager, serving various industries, including the automotive, appliance, and water and processing technology. Good morning, Shelley, and thanks for being with us.
Good morning. Thanks for having me.
You're welcome. We do have one more individual that will be joining us a little bit later on, and that is Faisal Khan from the Ministry of Labor, Immigration, Training, and Skills Development. And at this time, I'd like to turn the presentation over to Angela to step us through the agenda.
Hi, so thank you once again for joining us today. I will lead us through the agenda, and then what will happen is Sean and I will be sharing the presentation together. So we will be going back and forth through the presentation for engagement. We will be saving the questions for the end for the panel, so we will make sure that we do leave enough time. So the focus today, and this is the first time we're presenting this topic as a safety connection, we're going to focus on around the white paper and the job aid. So we're going to talk about battery electric vehicles, the market and the funding that has been provided that has created the need for this knowledge and this information to be shared. Then we'll get into the white paper, and we'll talk about how the battery electric vehicles and the introduction and increase of the demand and supply on the roads have affected employers' duties and responsibilities. We'll talk about the safety hazards associated with them, and then we'll get into the job aid, which will turn around and focus on controls that can be implemented to address the hazards associated with working on and around the electric vehicles. And then we will move on to the roundtable. Over to you, Sean.
Thank you, Ange. So just a bit of a brief introduction to where Ontario sits in the battery electric vehicle market. So as many people here are well aware, Ontario is fast becoming a leader in the green energy sector, especially around electric vehicles. The electric vehicle market globally is expected to grow from about 2.5 million in 2020 to an estimated 30 million vehicles by 2030. And the Ontario government is really working to position the province as a leader in the supply chain. And we'll talk about the funding on the next slide. Ontario is the only place in the world that the 6 largest automakers all call home. And the past 3 years, Ontario has attracted more than 28 billion and growing in automotive and EV investments. This does include 7 billion by Volkswagen for the St. Thomas battery plant, and we've also just heard announcements made by Honda in the past couple of weeks. Additionally, through the Skills Development Fund, Ontario's investing almost another $5 million to upskill over 360 technicians and job seekers to gain the skills that they need to launch or transition their careers as we move from ICE vehicles to battery electric vehicles. So with this in mind, this is where WSPS saw an emerging market and emerging hazards and decided to look into it. And the way we did, starting last year in the fall, and it was released in March, we developed our EV white paper, Plugged into Safety. There is a link here that anyone can click, or you can use the QR code if you would like to see that now. Additionally, we will be sending that white paper and the job aid out in the email that comes after this presentation. The goal of this white paper is to support our industry groups and associations to identify at this stage the hazards working with or around battery electric vehicles. And the focus of this paper was everything that happened prior to battery manufacturing and then everything that came after vehicle manufacturing. So we did exclude the vehicle and battery manufacturing processes, just focusing on everything before and after. Additionally, we did develop a job aid, which we will be discussing later on, to help support employers with identifying the hazards within their workplace associated with BEVs, as well as identifying the legislation and some potential controls for those hazards.
So, wanted to start with setting the framework around how the white paper and the content of the white paper came about. So, when we started to do our research, we were working with different industry associations within Ontario. First thing that we did acknowledge in our research was that there was not a lot of information that had all of the hazards that were associated working on around the battery electric vehicles in one place, and it didn't clearly identify the tasks that were associated with the hazards. So we started to work with the collision center, repair shops, auto recyclers, and the associations that represent these businesses, and also with different educational institutions and on the Ontario Vehicle Innovation Network, and with the purpose of trying to understand what do we know and what don't we know when it comes to working on and around, and also taking into consideration the life cycle of the vehicle. So the popularity of these battery electric vehicles started to gain traction around 2010, 2012, started to see more prevalence. Yes, there was the Prius on the road before then, but that's when we started to see. So we could see that, in the early we have some vehicles now that have come to their end of life, and so that there are different hazards associated with the battery at different stages of the life, and there are different hazards associated with the battery in good and damaged condition. So we wanted to make sure we understood what were the hazards and what sectors did they impact. And so that really set the framework for the white paper in these discussions. And through talking with these different industry associations, we really did see that there was a huge knowledge gap, even though these vehicles have been on the road for 10, 15 years now. And that this is where we really needed to start. It was really starting at the foundation of understanding the hazards and then getting into the legislation that applied to support the employers and then support these businesses with understanding what they needed to do and how to keep their workers safe. There was definitely a sense of apprehension that was shared with us in some of these sectors, and some businesses were choosing to stay away from working on and around taking in electric vehicles because of the lack of knowledge and the understanding of the hazards that are present. Excuse me. So moving on, so we wanted to say, so we started with the paper in the research. So the framework is really about hazard identification with an Ontario focus. This list is definitely going to evolve. So some hazards that were on the list, more knowledge will become available as we on this journey, this learning path, gain more knowledge. So the list will evolve and change. So the white paper is what we knew at the time of working with. So we started gathering and working with the industries September through until January. So that was 2023 until January 2024. So it was a shorter time span, so it is a reflection of what information we collected at that time, working with those different industries. And we wanted to, obviously, the scope of the paper, we had to provide a scope. So we limited it to the battery electric vehicles with lithium ion batteries. Lots of different batteries out there, but the scope of the paper was limited to the lithium ion batteries. And we wanted to focus on identification of hazards that doesn't include the battery build process that Sean spoke to earlier. And we are considering the life cycle of the battery and the impact to different industries. So when the battery is in good repair, damaged, or end of life, and how the hazards change throughout the life cycle. So there was collaboration with industry partners and educational institutions because there isn't just one expert out there. We are not experts either. We are on this learning journey together, and the evolution of this knowledge will continue to grow as we move on.
And this brings us to our first polling question. Thank you very much, Ange and Sean. So Emily, I'm going to ask that you bring the polling question across. So what sector are you employed in? So we have manufacturing, auto sales, auto service, government, or other. And if you notice over there on the right-hand side, it's live. We can see the answers live. So we have, let's see, almost 30% to manufacturing. We have 33% in government and 33% in other. We have almost 100 people responding. So we're going to wait another 15, 20 seconds. Okay, we're going to close the poll in about 5 seconds. Okay, so let's scroll up to the results. Thank you everyone for participating in that. So Ange and Sean, both 29% or 27% rather manufacturing, 0 in auto sales, 4 in auto service, 33% in government, and 34% in other. So I'll let you carry on from there.
Excuse me. Apologize. So
Okay, so we do have another polling question. You think I'd be on the ball with this? So, do you currently work with BEVs or operate them? Yes, work with them. Yes, work with their batteries. Yes, operate them, or no. BEV is battery electric vehicle. So 95 respondents so far. 1 with electric bikes. Thank you, Angie. I saw your question earlier as well. Do you have a question, Ange and Sean?
Yes, we would include hybrid vehicles.
Okay, thank you. Okay, we'll close the poll off in about 10 seconds. Okay, we're going to close the poll off. And we see the results. So about 16% yes, work with them. 10% is work with their batteries. 19% is operate them, and then no is at 53%. Thank you very much, everyone, for participating. And for our third polling question, what type of tasks do you perform on battery electric vehicles? So select all that apply.
Are we ready to close that poll?
In about 10 seconds, we're going to
Okay.
close the poll. I'm just looking at how many respondents we have.
Thank you.
You're welcome. About 5 seconds, we'll close the poll. Okay, Emily will close the poll, please. And as you can see the results there. So there we are, battery manufacturing, it's at 9, vehicle repair service at 25, operate only. Battery repair at 4%, recycling at 9%. We have troubleshooting at 8%. Perfect, and the poll is closed. Thank you everyone for participating.
Yes, so also we should clarify that for the scope of the paper, the charging stations for this particular part of the project that we were working on, the charging stations were out of scope for the project. Not to say that it will not be included for future projects. So as the prevalence of battery electric vehicles increases, and as workplaces bring these vehicles into their workplace, excuse me, that brings new hazards. So with that, we wanted to go back and look at the employer's the duties and responsibilities. So going back into the Occupational Health and Safety Act into Section 25, this is where you find the duties and the responsibilities of the employers. And we want to specifically highlight Section 25 to A, D, and H. So the reason why is obviously with these new hazards coming in, it's time to, go back and reevaluate. Are we doing everything that we should be doing within our workplace to keep our workers safe? So when we look at 25 2A, it says provide information, instruction, and supervision to the worker to protect the health and safety of the worker. So when we think of this in the context of working on and around the BEV, there's new hazards that may not have been. So we're looking at chemicals, we're looking at electricity that may not have been something that the employees or workers would have done and worked on and around in the past. So some things that the employer may have to do is implement new policies and procedures to address these hazards. Also, they may need to train workers on equipment, including standard operating procedures, how to operate that equipment safely. And the supervisors must instruct the workers on how to use that equipment. Are some examples. So that's not all encompassing, but some examples. When we look at D, acquaint a worker or a person in authority over a worker with any hazard in the work and in the handling, storage, use, disposal, transport of any article, device, equipment, or a biological, chemical, or physical agents. So let's look at this at the context of a battery, both in good condition and in a damaged state. So obviously those hazards will be different when the battery is in good repair or has been damaged. So it's important that the employer understands and is prepared to deal with the battery in both of those conditions. So what are the hazards? How are we going to handle and store a battery in good repair versus a battery that may have been damaged, whether it be in an accident or it has been end of life? So there are different situations that create different hazards that we would need to be able to take into consideration and address. Then the last one is taking every reasonable precaution in the circumstances for the protection of the worker. So, have we really taken the time to prepare the workplace for this new type of work that we're bringing in? Have we evaluated the tasks that we're going to be asking the workers to do? Do we understand all the hazards? Do we have the right policies, the procedures, the equipment? Do we have the right training in place? Are we taking the time to make sure that we're keeping all of our employees safe and will be able to do the work safely? Moving on, so getting into the most common types of hazards. So, when you typically go into Google or if you hear in the news, the most common or most prevalent hazards that you will hear about working on these battery vehicles. If I say BEV, I'm talking about battery electric vehicles. Working on a BEV are going to be electrical compared to an internal combustion engine. The electrical hazards are going to be different. There's going to be both the low and high voltage that will create new hazards in the workplace. You'll often hear about thermal runaway, and we'll spend some time talking about what that is, when the risks of it being present are. And then the third piece is the chemical. So inside of the battery, there's going to be the electrolytes, and between different batteries, there's going to be different formulations for the electrolytes in there. And that is a whole other category of hazards that need to be taken into consideration. And depending on the task that's being done, the prevalence of these hazards will change. So, although these are the most common hazards that we see and hear about, there's actually a lot more that we identified in the white paper, and we are going to start going through some of those in a few slides. But before we do that, we really want to take the time to understand in the list of hazards, they're not going to be applicable to every workplace. So it's really about taking the time to stop and think about when you bring these vehicles into your workplace, who's working on them? What are they doing? What hazards are associated with those tasks? And these will help us formulate what are the next steps that we have to take in order to ensure that we're taking the reasonable precaution that we talked about in this duties of the employer. So it's really understanding what has changed in our workplace with this new type of work that we have taken on. So who's affected? What are they doing? What equipment and tools do we need to use? Where are we storing the equipment and tools when we're considering whether the battery is in or the vehicle is in a good condition, end of life, or has been in an accident? Because once again, the hazards associated with the battery is going to change. So the intention of this piece of the conversation before we get into the actual hazards is to slow down and think about there's going to be a long list, but really what is going to be impacted into your workplace is really going to be answering these questions, is going to be a guided conversation, and it will help you focus on which elements are applicable to you when we go through that hazard list. So the following list of hazards were identified in the white paper. So you'll see that there is a very long list. However, it will change and grow as our knowledge changes and grows. Not all hazards listed will be applicable to all workplaces. It is the employer's responsibility to identify the hazards within the workplace and communicate the hazards to the supervisor and the employees. And the purpose of this hazard table is to provide support to the employer with this first step with acknowledging what the hazards are.
Okay, thanks, Ange. And now we'll move into our list of hazards that we did identify in the white paper. And you will see we list the hazards. We broke them down by categories, so our 6 hazard categories. What are the details of the hazard? What industries do we expect to be impacted? And then we do list the applicable legislation that may be involved with this one. So the first 2 we have are musculoskeletal disorders, and these predominantly come from the weight and size of the EV batteries. So depending on the vehicle, the lithium-ion battery can weigh between 300 to 600 kilograms or more. So obviously, if you're trying to move that manually, you probably will not be able to. But even moving it with lifts or carts, if those are not well maintained, they could still have exceedingly high force, resulting in a risk to the worker's shoulders, back, etc. The other related one in the realm of MSDs is awkward postures. When we are installing or working on the batteries, they're often in awkward spots. In hybrids, they're often in the trunk where you're having awkward reaches. On full electric vehicles, they're usually in the floor, which means working overhead to do the assembly, disconnections, etc. So for both of these, we might be seeing them in manufacturing as well as auto body collision, repair, or taking apart for recycling. And when we're looking at the legislation, we're looking at the employer responsibilities for both, as well as Reg 851, the industrial establishments, Section 45, which is on material handling, lift, carry, and move things safely. Now we're moving into our safety hazards. And the first one we have is very much related with the weight crush hazard, right? Anytime we are moving a half-ton battery around, there is a huge risk of it crushing, whether it be a foot, a finger, or potentially a worker, depending on the way it's being done. And then this last one that I'll talk about real briefly is our low voltage electrocution. This would be very similar to any other vehicle that has a 12-volt system. So there is a risk of that low voltage electrocution, although it will be quite a bit smaller, I would say, compared to the one that Angela's going to talk about next, which is our high voltage.
Thanks, Sean. So the next two hazards that we're going to talk about are going to be the high voltage and arc flash. So when we look at both hybrid and battery electric vehicles, there are two parts to the electrical system. There's the low voltage and the high voltage. The high voltage system can be anywhere, typically between 300 up to 800 volts. And so that is a new hazard that's quite significant. That's some of these workplaces, auto body dealerships, collision centers, recyclers, emergency response and towing would be exposed to that may not have had the familiarity or exposure to that hazard. So we will talk a little bit more about that. So the high voltage system, obviously coming into contact with that is essentially going to be death if you are coming into contact with that energy. Then there is the risk of arc flash. And this risk of arc flash, when the battery is in normal operating condition, is relatively low. But when we get to end of life or possibly a vehicle that has been damaged, there is a potential for an arc if there's been a short circuit or if there is going to be a disconnection. Let's say that the battery is 10 years old, it's never been disconnected before, there could be some corrosion. Depending on how we approach the battery too could also be a hazard. So there is the risk of electrocution and arc flash. The next
Okay.
one, oh, yeah, sorry, go ahead.
Yep. Another hazard that many people don't think about when working with EVs is if you are doing welding, where do you make the welding connections to the vehicle body? This is something that we should be following the manufacturer's recommendations, but we do have the high voltage battery within the floor of the vehicle and high voltage cables running throughout. So make sure we do follow manufacturer's guidance on that. The first of our big three hazards that we're going to talk about, though, is thermal runaway, leading to potential fire or explosion. This is, like I said, one of the big three, and I think something that people have thought and been concerned about, and we've all saw, I'm sure, a lot of news coverage on EV fires. So what is thermal runaway? A thermal runaway event can be triggered by damage to the battery cell, either as a result of shorts, internal or external temperature. When one of these faults elevates the cell temperature, the material within the cell begins to break down, and this can trigger an exothermic or self-fueling reaction. As the temperature in this one cell increases, the decomposition rate increases. So it starts spiraling up in terms of temperature. And this can lead to a full-blown fire or battery explosion. What tends to happen with an EV battery is there are many, many, many cells. So when one cell starts going, nearby ones will also start to heat up and also join in the exothermic event. And this is when we get to a full-blown EV battery thermal runaway, which can be a very devastating and costly issue. So what can cause these faults? Well, the first one, it could be a manufacturing fault, either within the battery cells or the assembly process. This we haven't found too many cases of, and when it has occurred, it often occurs fairly quickly. Another one, this is becoming a little more of the past for modern EVs, would be overcharging or discharging of the batteries. We do see this more in some of our cheaper non-certified things like e-bikes or scooters, where they do not have an advanced battery monitoring system that prevents that. But most of our modern EVs would have that. There is always a chance that someone is doing some tinkering at home or in the garage and starts to modify the battery or the battery management system, which could cause issues. But the most likely one would be through collision or damage, right? Where the battery itself has become mechanically damaged, resulting in a short within the battery, and this can trigger the thermal runaway event. What can be tricky, here's where we will start talking about storage, is it might take anywhere from minutes for the event to begin to days or even weeks after, say, a collision for a thermal runaway event to occur. Some of our early warning signs may include noise, a hissing or a popping sound, gas production like hydrogen, carbon monoxide or dioxide, ethylene or methane. These may be able to be captured with gas monitoring systems in a storage area, as well as a rise in temperature, which you might be able to catch with a thermal imaging camera. Once it starts advancing, a chemical cloud may be produced. This is something we do not want to go near, as there, as we said above, are many toxic gases that we do not want to be inhaling. This is not traditional smoke. And then ultimately, the thermal runaway event can be a truly devastating event, resulting in most cases the total loss of the vehicle, but could also spread to any nearby vehicles or structures. And due to the battery in most EVs being highly inaccessible in the floor of the battery encased within a shell, most EV fires cannot be put out and must burn out naturally. Right, so it's not one where we can hit with the fire extinguisher and put out quick. However, despite what the news and at times Facebook might want us to believe, BEV fires are quite rare, with about 25 fires per 100,000 vehicles on the road. This is opposed to over 1,500 fires per 100,000 for gas or diesel powered cars. And one of the things that we found with all vehicles is the older the vehicle, the more likely it is to catch fire. So while they are rare, they are definitely covered on the news, and they often are total loss of vehicle and difficult to put out. So there is a right to be afraid and worried about them, but it's not as common as we might believe.
Okay, moving on into some safety hazards. So once again, the risk of these hazards being present really will depend upon the state of the vehicle and the age of the vehicle. So unintended movement or starting, there's a potential for the vehicle to start and unexpectedly move if the proximity key is left in the vehicle. And this could also happen if there is a short circuit. So once again, the risk of this happening when a vehicle is in good repair and is quite low, but it depending on the state of the vehicle and the condition and the tasks that are being done, it could be a hazard. When it comes to identification of the hybrid or the BEV vehicle, so some hybrids and BEVs may not be identified as having the high voltage system. So just looking at the vehicle itself, it might be hard to tell what kind of vehicle that is. All high voltage systems will have the orange cabling inside, but telling what type of of vehicle that is from looking at it is not necessarily intuitive. And the last one that Sean did speak to, vehicle modification. So when we talk about, souping up cars and tinkering in driveways, when it comes to electrical vehicles, when there are modifications being made, it could have an impact on the battery management system, especially if the modification does have to do with increasing the capacity of the battery. In our conversation with one St. Clair College, for example, they were discussing there was a Ford F-150 and they were actually in the school environment. So in a controlled environment, they were doubling the size of the battery by actually connecting a second battery to increase the voltage and the power within the vehicle. But for the average person in their garage to take a task to undertake those tasks could have impact on the battery management system and create other hazards. So as the marketplace grows and that there's more modifications made to these battery operated vehicles, the hazards associated with those modifications could vary. Getting into chemical hazards. So obviously when the battery is in good repair, the risk of chemical hazards or exposure to chemical hazards is going to be fairly limited. But with the lithium ion batteries, they do contain the electrolytes. And one thing that is known is that the actual makeup of the electrolytes isn't well known or often shared. So you don't actually know what is inside of the actual makeup of the electrolyte all the time. So there is a risk of exposure. If the battery is damaged, some of the electrolytes could cause, there could be a toxicity or corrosion if you're exposed to these, causing both skin and respiratory, so burns or respiratory issues in the different sectors. So it really depends on the state of the battery and the electrolyte that is inside of the battery as to what that chemical hazard would be.
Okay. Another risk that we have is potential flammable chemicals in the battery, as well as a risk of, depending on how the cells or modules are packaged, we have saw situations where individual battery cells have been packaged within cardboard or other combustible material. There would be a risk that damage could occur during transportation and make it very difficult to identify before you start taking everything apart or catch fire during transport. Another concern, especially when dealing with high voltage, would be becoming contaminated with oils or other flammables on your glove or clothing and then coming in contact with electricity. So while rare, there is a risk here that might not otherwise be considered as people move from ICE vehicles to EVs and back and forth in something like a collision or an auto body shop. And then additionally, there is a risk of some of the electrolytes within the battery itself becoming overcharged, overheated, leaking, and the LiP46, that is lithium hexafluorophosphate, there we go, that's a tongue twister for me, it's not just Dave today, can be converted into hydrofluoric acid, which as we know is a highly dangerous and corrosive chemical when exposed to elevated temperatures. And the temperature that this conversion happens at lowers as it is exposed to moisture or humidity. So while rare, if you do become exposed to that, there is a chance that it could be converted into hydrofluoric acid, doing severe damage to the body. So just something to be aware of and do a little bit of research into. Anything to add on that one, Ange, before we move to stress?
No, that's once again, it depends on the vehicle and the state of the battery. So the last class of hazards that we included, and this one was prevalent across all sectors, but the degree of this hazard really did vary. So we did see, as we talked to different workplaces, especially the smaller workplaces, there was a high level of stress of getting involved with taking in the battery electric vehicles and working on the batteries, because there is such a wide range of knowledge and support. So if you are a Tesla dealership, the Tesla has, the knowledge that they're sharing and they're providing to those dealerships is going to be very different than the small mechanic shop down the street, and their comfort. However, there is a desire to take this on, as it is another market that is growing, and there are financial benefits to getting involved. So we did notice that there was the presence of the hazards, of stress and anxiety with bringing in the BEVs into their workplaces, because there was these unknown hazards, and the what to do next and how to deal with the hazards was definitely acknowledged across multiple sectors. So that is an overview of the hazard table that we talked about. So really, when we started this journey of the white paper, the intention initially was just to focus on hazard identification. But as we worked with our sector partners and the different associations, and we started to identify the hazards, there was a conversation about, so what do we do now? You've told us what these hazards are, but what's the appropriate next step? And through discussion, we decided that we needed to provide that next step in a timely manner, because just to say this is the hazard and to walk away and not provide that next step, there was more stress associated with that, because now we have the understanding of what the hazards are. The so what do we do now, without having that knowledge and comfort, was definitely something that was discussed. So that is where the job aid came in, and it's really focusing on controls. And so we've identified the hazards. The next thing that we needed to do is provide some guidance to how to control these hazards. And when we talk about hazard control, we're talking about how do we eliminate or minimize the presence of that hazard in the workplace. When we talk about the context of a control, there may be legislated or regulatory requirements that we can find in different legislation or applicable CSA standards. Controls must adequately minimize the hazard. We want to make sure that we protect all workers who likely could be exposed. So once again, this is getting back to who is doing the work. What are they being exposed to? What are the tasks that they are doing? And ensuring that we are providing them the protection to minimize the exposure. And lastly, when we are talking about controls, we don't want to implement a control and then that control can be associated with the implementation of new hazards. So we need to pause when we are implementing controls and evaluate whether or not the control is effective in doing what we think it's going to do and not create new hazards. So you can scan the EV White, the job aid is, you can use the QR code there, or we will send out the link afterwards. It is also on our website. The controls, you'll see that the job aid, it's a checklist that has been developed to support employers with identifying the hazards associated with working on and around the electric vehicles, as well as the legislative references, so we can assess. That's the assessment piece, and the recommended controls. The checklist can help us recognize, assess, and control hazards that are brought in. When we look at the job aid, you will see that there is a very long list of recommended controls, and not just like we mentioned earlier, not all hazards will be applicable to all workplaces, but not every line item in the job aid will be applicable. It really will depend on the tasks that are specific. And the reason why the list of recommended controls is so long is the task list could be very different for each hazard.
Okay, and here is just an excerpt from what the job aid checklist looks like. So again, it's being identified, like Anne said, to help support employers with identifying, assessing, and controlling the hazards with EV batteries, because especially in things like collision and recycling, there is a whole brand new set of hazards that employers have not previously had to deal with or have dealt with at a very low level before. So the one that we showed here was electrocution high voltage. So we discussed this, but again, we do have high voltage systems that may exceed 800 volts and counting right now. The next column that we do have is it applicable to your workplace? Right, just a real quick check, yes or no. If the answer is no, the other 3 columns do not need to be worried about. We did list our legal and other requirements, so we do have all references that we could sort of think of and put together from the Occupational Health and Safety Act, Regulation 851, CSA standards, fire code, and a few other sources throughout the list. So again, not every one of those will be applicable to every workplace, but we do have the full list available for you. And then in checklist form, we have our suggested controls. Again, not every control will be needed at every workplace, but the way this is designed is as you've implemented a control, you can check it off that yes, this is one that we have and we've implemented. We have suggestions like FR-rated clothing, electrically rated PPE, lockout tagout training are all things that might be applicable here for working on high voltage, and then room for any other additional controls that are being implemented at the workplace in case we didn't think of anything or you're going above and beyond what these suggestions are. So this really is a document to help employers make sure that they have their hazards recognized and then as many controls put in place to keep their workers safe, which is our ultimate goal, keeping workers safe every day so they can go home to their families.
Thanks, Sean. So one of the highest risk hazards that is associated with working on and around the battery of the vehicle is going to be that high voltage system. So typically the systems will be between 3 to 800 volts. However, the new Hummer, I believe, is 1,000 volts. So they are increasing in voltage, and there is going to continue to increase. And with that, we wanted to highlight hazardous energy control. So when we talk about hazardous energy control, that's how we are going to minimize and eliminate the risk of coming into contact with that high voltage energy, and that is through lockout tagout. How lockout is performed on the high voltage system is going to vary between the manufacturers and the vehicles. It could be a fuse that is used for that high voltage system, or it could be a plug. A common misunderstanding is that pulling the high voltage plug or fuse and placing it on a desk or away from the vehicle is hazardous energy control. This isn't true. This is a form of de-energization. So it is removing energy from the system, but it is not hazardous energy control lockout tagout. When we are talking about lockout tagout in relation to hazardous energy control, we are talking about a form of controlling the energy with a physical barrier that prevents the energy from the system being re-energized. So there is a physical device that is used to prevent the energy from being able to be put back into the system and allowing the person that's doing the work on the system to have care and control of allowing that energy be put back in. So allowing that high voltage system to be reconnected. So de-energization and lockout tagout are not the same thing, and we just wanted to highlight that. We want to ensure that you know that the OEM requirements for lockout tagout of the system will vary, but we wanted to also talk about what some of those steps are that are taken two that are typically found within a lockout tagout procedure. So typically there's, how do you shut down, letting people know that the vehicle is going to be shut down, the people in the area. Then we get into isolating the system, so de-energizing it. So that could be for a high voltage system, pulling that disconnect, allowing time. It could range from between 5 to 10 minutes to allow the capacitors to dissipate, remove the stored energy. And then there is a physical device that's applied to the disconnect that would have a lock and a key that allows us to prevent the physical that prevents the inadvertent energization of the system. Then we would verify to ensure that lockout is we would test to make sure that the lockout is effective. We would perform whatever maintenance or service tasks that we need to do after we've confirmed the verification of the system is there is no energy in the system. And then we would just go through these steps in the opposite order when we are finished the tasks that we are doing. So some elements and some PPE that may not be typical in a workplace prior to bringing in battery electric vehicles could be high voltage gloves with a leather overlay. You may have had safety glasses before. Then there could be arc flash clothing depending upon the tasks that are being performed. Multimeters with a high voltage category 3, and this would be used in that step to verify that the energy has been disconnected and removed from the system, so confirming that there is no energy in the system. There could be isolation mats and blankets that could be used. Another thing that service places may not have had in the past is insulated tools. So depending on the tasks that are being completed, we may need special equipment and tools, lockout devices and tags, and possibly safety barriers, depending upon, once again, what the tasks are being performed.
Okay, thanks, Ange. Now we'll talk more about some of the prevention strategies for thermal runaway. What we're really thinking about here is if a battery goes up or a car goes up into a thermal runaway event, how can we minimize any damage being done or spread? So when we're looking at batteries, we do have the goal of limiting the number of batteries that we're storing, especially storing together, right? The greater number of the batteries, the greater risk we have for a thermal runaway event to occur, and the worse it will become because it could easily spread to another battery. So we do want to limit the fire load and make sure it's within the capabilities of our fire suppression or isolating systems like firewalls, sprinklers, or deluge systems. May consider storing in remote areas of a building or outside of the main building. So if it does occur, it will not spread to the main building. We do not want to store different types of batteries together, such as lead acid and lithium ion. We talked about limiting the number of stored batteries. If we are going to have a lot of batteries, separate different stockpiles so it cannot go from one to another, have barriers in between or enough distance for that to occur. Also, be cognitive of any other flammables or combustibles that are stored near those batteries. So that's with batteries, limit the numbers. Another thing that we can do is start monitoring it. There have been some workplaces that are starting to monitor the battery stockpiles with thermal imaging cameras. So if they do see a temperature increase, they might be able to start a response earlier, as well as some gas monitors, looking for things like the methane, carbon monoxide dioxide that may be produced depending on that battery's chemistry. So those are a few of the things that companies are starting to look for, but overall, we're still fairly early in this journey of figuring out how to control thermal runaway, what to look for. With vehicles, here we're particularly looking after we suspect the vehicle has become damaged or may be damaged. If you do have a severely damaged vehicle, we have had some recommendations of putting it in, a metal shipping container where if it does go into a thermal runaway event, the container will contain it, or quarantining it in an area away from other vehicles and any other combustible material. So isolated within a parking lot, let's say, where if it goes up, we can monitor it, we can call the fire department, but will not spread to anything else. If we do have damaged vehicles where, let's say, the roof or bodies become damaged and water might make its way in, we want to tarp it to ensure that does not occur, because water intrusion into the battery could increase the risk of a thermal runaway event while in storage. And do not allow water to collect over, under, near the battery, because again, submersion may cause the shorts, leading to thermal runaway. Typically, when we do have a thermal runaway event that's occurred, our go-to response is evacuate, as opposed to try to put it out, call the fire department, which would be the situation most of the time. And then finally, once we've implemented our controls, we are going to go through and reevaluate to make sure that the control is working, that it has reduced the risk to an acceptable level. The other thing we're going to look for is, have any new hazards been created? Blind spots, maybe we have a procedure, we're using more PPE, increases the risk of developing MSDs, and we need to change some of our working procedures. So we're going to go through, look for any new risks, work with our joint health and safety committees, supervisors, employers to make sure that it's working, no new risks have been produced, and the controls have reduced our overall risk level. Okay, that's the main body. We have a couple additional questions for you now.
Great, thank you, Sean. First question of a series of 3 here is going to be, what EV hazard is your top concern? So we have electrical, thermal runaway, chemical, arc flash, other. So right now it seems to be thermal runaway. It's around just over 60%. And we'll keep this poll open for another 10 seconds. Yeah, we also have some comments as well as chemical. All of them, yes. Carly, yep. Okay, Emily, can you close this poll? There we are. So we see thermal runaway at roughly 64%, followed by electrical and chemical, arc flash and other being 3. And Carly, can you bring over the next polling question? Or sorry, Emily? So this question here, we're going to ask everybody just to kind of type it in the comment section, or in the chat feature rather. What is your biggest knowledge gap between like the battery electric vehicle safety? So again, I'll read the question. What is your biggest knowledge gap related to battery electric vehicle safety? And it might be a tough question to answer. We do have one, Laco Tago. Thank you, Victoria. Safety protocols associated with research activities and post-secondary. Monitoring for fire safety. Yeah, lots of unknown. Yes, thank you. General awareness of the hazards and controls. Removing battery. Yeah. Lack of experience. Disposal. Servicing the vehicle. Yes, thank you. Storage or damaged vehicles, especially if they do not have a ton of space, and we have fire, charging hazards, storage and shipping, to name a few. So thank you very much for those responses. And we're going to close that one off, and then we'll ask Emily to bring over the last polling question. And again, we're going to ask you to type the answer into the chat feature as well. So was this safety connection and the resources shared helpful to you so far? And we will be following up with an email with some resource links to the EV white paper as well as the job aid.
And we still have our
We still have our panel
discussion
discussion.
So as we
Perfect,
finish
thank you.
that polling question, so once again, this journey of knowledge and awareness around hazards with battery electric vehicles, although with the vehicles have been around for over 10 years, still there is a lack of knowledge and in with the employers and understanding what those hazards are associated with the tasks and understanding the applicable legislation. So looking ahead, employers need to be better equipped to anticipate the hazards associated with battery electric vehicles and how to apply the legislation or the applicable legislation with those hazards. WSPS's research and experience with this subject, there's a few key findings that we did identify and we will continue to, there's a need for, is resources to support Ontario employers in understanding and complying with provincial legislation requirements. Then we also found that with the battery electric vehicles and hybrid vehicles, the training standards for automotive service technicians, there are gaps there. So when we talk about the requirements, the accreditation and the what and who can perform this and what the requirements are, there needs to be some standardization. There are some updates to some of the CSA standards that need to be taken into account, and there is a requirement for individuals providing training to training on battery electric vehicles to have some appropriate credentials. We did find that there is lack of that someone can walk into Joe's auto shop and say, hey, I'm here to teach you how to work on and around the battery and the hazards, but what credentials that they have, there's no requirements at this point. So there's a need to look into that a little bit more. So that's some of the next steps in looking ahead that we need to take into account. And once again, this isn't all aspects that WSPS will not be taking on these tasks. These are just some of the gaps that we did identify within the industry and sectors. So at this point, we're going to ask for Shelley, Trevor, and Fazil to join us, and we're going to open the panel discussion. So what's going to happen now is Dave's going to go through some of the questions that have been put in, or if you have any questions you would like to ask the panel, this is a time that we can have an open discussion. So if you can type those questions into the chat, Dave will take the time to read them out, and we'll address as many as we can in the next 23 minutes.
Thank you, Ange. Before we get started, Fazil, can you just give us a brief introduction of yourself? I didn't get a chance to introduce you, and I thought we'll just wait till we get to the panel discussion. So, Fazil, if you don't mind.
Sure.
And welcome, Fazil. Thank you.
My name is Fazil Khan. I'm the Senior Manager for the Specialized Professional Services. So that's the engineers, ergonomists, and hygienists. I myself am a mechanical engineer.
Fantastic. Thank you very much. So before we get started into the questions, just want to ask the panel if there are any general comments or anything like that you want to say about the presentation or about the direction of the battery electric vehicles and where they're going. Shelley, if we want to start with you.
No, so I think in regards to the presentation, I think it's a good start for employers to use as a tool to work through that risk assessment based on the processes that are happening in their workplaces. So I think the risk assessment tool as well as the white paper are good resources for employers to start with, so they can start working through these hazards.
Fantastic. Thank you. Trevor, yourself? Any comments on what you're seeing out there as well?
Yeah, I did want to sort of echo what Shelley has just said. Kudos to WSPS, Angela, and Sean as providing some good materials for the industry in terms of just identifying what some of the major hazards are and where you can start. They can't cover everything. They can't get into every detailed situation, but this gives you a good overview of some of the things that you should be looking at and approaching it from the same criteria that you would for any other hazards in your workplace.
Fantastic. Thank you very much. I'm going to get into our first question. And ladies and gentlemen, I'm going to do my best to work through as many of your questions as we can. If we don't get a chance to get to them. We will be sending out an email after this presentation, probably a little bit later on today, and that will include the contact information for Angela, Sean, I believe Shelley, Trevor, and Fazil. We'll do our best to answer those questions on an individual basis at that point. The first question that we have is the one that I can see right here in front of me, just the way my screen is. So can you explain a bit further regarding the health risks specific to chemicals emitted, best way to mitigate personal safety when dealing with chemicals being released? Is there a specific type of mask to be worn, etc.? And I think that's a good question, probably a complex question. Does anyone want to give that one a try?
So I guess I will just high level, like, so with
Sure.
this would be one where depending on the electrolytes, like so typically you may know what some of the chemicals are in the electrolytes. That could provide some guidance to the type of filtration you should be using with the respiratory protection. But if you are not aware or concerned, that's when you would want to reach out to our organization, and we can ask the more specific questions to our industrial hygienists, our occupational hygienists, to provide some more guidance. So once again, most of us are generalists, except for Fazil, and we've got some ergonomists on the line, but without being the occupational hygienist, it's hard
Yes.
to give the specific answer.
Yes.
Does anyone else want to add further comment to that?
I will add, if you see gases, smoke coming out of a battery, best advice is to stay away from it and evacuate the area, because it is different from what's in the battery and then what could be produced when chemical reactions due to heat, electricity, or mixing occur.
Fantastic, thank you. There's a question that came up a little bit earlier in the presentation, and I want to ask this just for the individual. And I hope that I wrote down the question correctly. I am an EV bicycle shop owner. Will the information in this webinar be relevant to that business or to my business? And can we just kind of look at that generally? And so I know we have battery electric vehicles where we look at automotive, but there's also the other sector around battery electric vehicles that are bicycles, or I don't even know.
I can start with that one.
Sure.
There will be a lot of similarities. A lithium-ion battery is a lithium-ion battery. A big difference between an EV battery and an electric bicycle battery would be size, as well as complexity of the battery management system. Right. So obviously, we have saw some of the devastating results of an electric bike fire on the Toronto subway. What was that, a month or two ago? And in that realm, there's also differences, and it's really easy to import an electric bike that has not been adequately certified, which to my knowledge is where we've saw many of those fires, versus it's a bit harder to import an electric car without being properly certified. So a lithium-ion battery is very similar to any other lithium-ion. The complexity and size of the systems would vary.
But the responsibilities and the duties of the employer, if you have workers working on the batteries itself, the duties and the responsibilities are the same, and the requirements to educate the workers with what the hazards are with the tasks and providing the appropriate PPE and procedures would be required.
Okay. Thank you very much. Do you have a question here? Okay. Do my best to convey it. Sometimes there are different legislative requirements for employees versus persons granted access. If there are batteries in a building, but a particular employer's employees only work on the floor / in the building, but not with the batteries, would you say that there's still a risk of those employees? And would the employer be responsible for implementing controls such as eye wash / shower stations to protect these employees? Good question, complex question. I'm not sure who wants to have a look at this one. Is anybody
Shelley or Trevor,
Yeah.
do you want to provide some guidance or feedback, or Fazil?
Yeah, in terms of there's always the employer responsibility to keep their workers safe. So regardless of who the batteries are owned by or responsible for, the employer does have to make sure their workers are safe. So even if the workers aren't directly interacting with the batteries, but they are in the same space, then definitely workers can raise that concern with their employers, with their supervisor, and they do have a responsibility to ensure that the proper safeguards are in place. Now, whether they put it in themselves or they work with the actual other party that's responsible for the batteries, that's something that the employer has to work out. But the responsibility is there nonetheless, regardless of, you know, who owns the batteries or not.
Thank you. Another question came up earlier is we're considering reselling used batteries for the auto recycling industry. But we have heard batteries can combust under circumstances, or sorry, under certain circumstances. And goes on like, what can be done with this? I know we talked briefly about it a little bit earlier in the presentation. Can we expand upon this? Maybe Sean, can you look at answering this one?
So just going back to storage, where they are minimizing any combustibles in the area, separating stockpiles of batteries, looking at even removing them from your main building into a fireproof container, also waterproof, very key there. So if there is a thermal runaway event, the main building and people are spared, making sure that we've trained people on how to identify if there's signs of a thermal runaway event going, start the evacuation. And then we are seeing more around things like the thermal imaging cameras to identify any early signs, as well as potential gas monitoring. Love Jeff King's comment there too. We have worked with him. If we are outside, it's a great point. Temperature control to minimize heating and freezing. Other things that make batteries unhappy.
Thank you very much. Okay, I have a question here, and it's for either Trevor, Shelley, or Fazil. And you might not be able to answer this, or you might not know what the answer is, but what changes should we anticipate to come in the Ontario Occupational Health and Safety Act? In other words, has there been any discussion, or is there anything that you can share with us with respect to this?
Nothing at the moment, very specific to EVs and EVs batteries. Obviously, there is a focus to look into it and see where the potential gaps are. But for the most part, the existing responsibilities under the legislation, the Act, there's sufficient coverage to deal with the sort of well-known hazards of these batteries. So there is adequate protection at the time. Anything that might come up new legislation would be something that isn't sort of well known or considered with EV batteries. That would maybe push us to do something different. But I think for the most part, there are enough adequate regulations on the engineering side, on the sort of occupational hygiene side to cover most, if not all, the hazards with associated with batteries, the EV batteries.
Okay, thank you. There's a comment earlier about silent operation of a vehicle and just some concerns around that. Just going to ask the panel here. Like when I think of silent operation, I think maybe of somebody driving, like I've been walking across a parking lot and I've seen an EV vehicle coming, didn't really hear it, and it kind of catches me off guard, or even those that are working on these vehicles in repair shops, so on and so forth. At least with an internal combustion engine, when it's firing and it's on, you know it. But with an EV, you don't necessarily know if it's engaged or not. So with that said, and I'm thinking along the lines of like parking lots, so on and so forth, and pedestrian safety. Is there anything that organizations should be aware of or even consider if they're working with EVs, like if they're repairing them and they want to start moving these vehicles around the shop or driving around? And because of the fact that they are silent, is there any precautions or anything that they should be looking into or even considering moving forward? So maybe Fazil based on, or
I
Trevor,
was going to say I can start too if
Sean?
you'd like.
Okay, yes, please.
Most modern EVs do emit noise while moving at low speed.
Okay.
Or reverse or forward. It could still become a problem if it's a noisy environment where it's likely still going to be quieter than an ICE vehicle. But I really think then it starts getting into communication and sight lines, where we're trying to minimize blind corners that people are going around, traveling with the vehicles, having good sight lines.
Yeah, I was just going to build off of what Sean's just said. I think you would probably want to reevaluate your traffic control plan that you have in your workplace. Reevaluate for the fact that this might be a quieter vehicle that people are not going to hear. So you may need to emphasize things like perhaps a no phone policy, no distractions. And it is really up to the employer as to how far they want to take that program. Like maybe you implement a policy that every time you're moving around your EV vehicle, you're going to honk the horn twice or whatever that might be. It's really difficult for us to tell you what the control should be, but these are some things that you might want to consider. Ensure that sightlines are maintained, people are not distracted, there are clean, clear paths of travel, and there's as minimal interaction between pedestrians and vehicles as possible.
Great, thank you. So I just want to kind of expand or go in a little bit to different direction with that. So Ontario businesses that are working on EVs, right? I know we talked a bit about the silent operation and moving them around, but when they're actually working on the EVs themselves, what sort of PPE is needed and how can these organizations determine the type of personal protective equipment that is needed? I know, Ange, you touched briefly on this during the presentation. Can you expand upon that or at least revisit it?
Yeah, sure. So it really is going to be dependent upon the task that is being completed and the hazards associated with the task. So depending upon what part of the vehicle that they're working on and what they're doing, the different hazards will create the need for different PPE. So for example, if they're disconnecting the high voltage system, we're going to need to make sure that we have safety glasses, we have the right gloves, we have insulated gloves with the leather overlay. We're not using gloves that are oily or damaged, and potentially the appropriate clothing to go with that, depending on what the task is. So it's really hard to provide a generalization with, it's really going to be dependent upon the hazard and the tasks.
Yeah. Okay, thank you. Quick question. Can thermal runaway also occur in hybrid vehicles? Sean?
Yep, and
I
the
know
answer
you-
is yes.
Okay. I was hoping the answer would be a little bit longer. Give me time to try to find
But yeah,
another question here.
A,
but-
a hybrid vehicle has both the advantages and disadvantages of ICE and battery electric. It has all the risks of both, all the hazards with both. Typically, the batteries will be smaller and slightly lower voltage, typically around 480 is my understanding.
Yeah.
But it still has all of those concerns, just a bit smaller battery.
Yeah, I'm going to ask a question with respect to that around like thermal runaway and hybrids and stuff like that. So one of the criterion of an effective control is that it doesn't create an environmental hazard. That said, how are hazard controls effective in protecting the environment in the event of a thermal runaway? So
Again, I think
Trevor?
it's always, I know we hate to say this, but it really does depend, I think, on the situation. Ideally, the thermal runaways event is occurring outdoors. I think that's probably the best case scenario if it's indoors. I don't know if Fazil maybe you could talk to some specifics around ventilation or other things that could be useful in a situation like that.
Yeah, it always goes back to having the process of doing your risks assessment, identifying your hazards, and then implementing the controls. That's always sort of the best case scenario with anything sort of new and different. You try your best to obviously identify all the hazards, and then that sort of leads you to mitigate or control them. So in that process, you would obviously want something that looks at the environmental potential effects, so that where you're doing the work, if there is a spill, if there is a release of something, do you have controls in place to contain the spill, or like Trevor said, have ventilation sort of to dilute the air so that the effect of the release is controlled and mitigated. So if you have robust processes for handling changes in your workplaces, like handling EV batteries and that stuff, then you should be able to identify the adequate controls for any sort of potential hazard.
Great. Thank you very much for those answers. I just want to respect everyone's time. It's 11:55 or 5 to the hour. We're going to ask one more question, and then at that point, I think we'll close it off and allow everyone an opportunity to log out and get to their lunch break. The question is this. I want to kind of go back to the lockout tagout, and this kind of complements the determination of PPE, but I know we covered it off quickly, and Ange, I'm going to kind of come back to you on this one. What does a lockout tagout program look like on an electric vehicle? I know we talked about it at a high level, but if we can kind of get back into that in maybe a little bit more detail.
I'm going to ask to pass this one over to Fazil for his comment.
Okay.
I've already commented on this, so I think
Okay.
having your interpretation would be nice, or somebody else.
Yeah, for sure. Again, clearly defined sources of power within the vehicle, and then controls to sort of disconnect the power and to keep it disconnected while you're working on the vehicle. So getting that information either directly from the manufacturer, if not, then finding the sort of a technical person that can help you make those identifications, and having the sort of clear understanding of the processes to take before you engage in any of the work. Some disconnect sort of traditional means of, we're used to like padlocks in industrial facilities and hasps and stuff like that, may not probably work on a car. You might have to come up with something a little different, but at the end sort of achieves the same intent, which is, you disconnect, you then isolate. So however physically you do that, and then you check to make sure that what your assumption of it being de-energized is accurate before you engage the work. So the nuances here would be just sort of the more sort of tools that you have to maybe implement or use to make your lockout effective, as you would for any type of sort of industrial machinery or that sort of stuff.
Fantastic. Thank you very much
Thank
for that answer.
Can I just add that it's
Yeah.
the isolation step that can be the real struggle when dealing with electric vehicles, because they often haven't been, we'll just say it hasn't been thought of how to do that in an effective manner with many during the build process.
Fantastic. Okay, panel, before we close off, any closing comments or any final comments that anybody wants to make? I personally think this is an exciting time in our lives and an exciting industry. I like where it's going. Shelley, what are your thoughts just quickly about where you see this industry going and how it's going to impact legislation?
So I think we're all sort of learning as we go, right? So I think, investigating and identifying the hazards and the controls may result in changes to legislation. We're certainly relying on work that other countries have done, because EVs seem to be more prevalent in other countries. So I think we're all sort of trying to work through that process. I mean, I'm an environmental person at heart, so I'm all for anything that can help the environment. And if this is the way to go, then we're going to take that challenge on. So I think that's all I have to say about that. Yeah.
Thank you. Trevor?
Yeah, I think this is an emerging area. We're going to see emerging hazards and new issues, like Shelley said. To Fazil's point, the current legislation is written in a way that it can be generalized to these various and new types of hazards. And we've seen this in the past, at least in Ontario, with things like ergonomics as well. I don't think when the Act and the regulations were first written, they were really considering musculoskeletal disorders to the detail that we talked about them today. So while the legislation and the regulations are sometimes general, forums like this and working with partners are a really good opportunity to help figure out how that applies and what types of hazards we are seeing, and we're monitoring that from our side as well, and then trying to push out that information to the industry to make people aware and get people on board, hopefully before they experience these issues themselves.
Fantastic. Thank you, Trevor. Fazil?
No, I think both Shelley and Trevor sort of did an excellent job, so nothing more for me to add.
Thank you. Sean?
Yeah, it's definitely an exciting time. It's not too often within our safety careers a brand new set of hazards comes around, but this is one of those times. We are learning quickly. We're figuring things out as we go. And it's definitely a time where a more collaborative approach from everyone and sharing what they've found, the hazards that they've found, the best practices for dealing with those hazards is immensely important. So we appreciate everyone who has shared and who will share in the future.
Fantastic. And Ange?
To just build on what Sean just said, the collaboration is going to be imperative for this to keep employees and workers safe in the workplace, and for employers to take the time to ensure that they really do understand the hazards and taking the right steps to keep workers safe every day.
Fantastic. Thank you very much. Thank you to all those on the panel. Ange, Sean, Fazil, Shelley, Trevor, thank you for joining us today. And thank you out there for signing up and tuning in with us. I hope you got something out of today's session. If we didn't get to your questions, we ask that you follow up. And we are going to follow up in email, but we ask that you follow up with us. We'll do our best to answer your questions. Mm-hmm. Enjoy the rest of your day and stay safe, everyone.
Take care.
Thank you.
Thanks, everyone.